This is the Essentials of Political Analysis. I'm Philip Pollock. In this part of the chapter, let's look at how one goes about describing nominal, ordinal, and interval level variables. Any variable can be described by two properties that it has. Central tendency, that is a typical or average value of a variable, or I would say the value that best typifies the variable. And in several cases we'll look at, there is no value that best typifies the variable. Why? Because of the other aspect of description. Dispersion, variation, or spread. They're all interchangeable terms. Dispersion. That describes the extent to which the units of analysis are distributed across the values of the variable. Are the cases, or the units of analysis spread out, or are they clustered around a certain value of the variable? There are three measures of central tendency. The mode of any variable is the common most value of the variable. You can find the mode of any at any level of measurement. Sometimes with interval variables it doesn't really help a lot to find the mode, but it's the only measure of central tendency that can be used with nominal variables. The median is a second measure of central tendency that can be used with ordinal and interval level variables. It's the middlemost value, the 50th percentile. So when you find the median, half the cases fall below the median and half the cases fall above the median. Same with the 50th percentile, and again can be used for ordinals and intervals. And then the arithmetic mean, the arithmetic average. This can be used for interval level variables only. Add up all the values, divide by the number of cases. This is for intervals only. Now, let's talk more about dispersion. In fact, I've chosen the examples in this chapter to highlight this aspect of description because I think it's neglected. It's underappreciated. I think we live in a very mean-centric, if you will, average-centric world in which people are very focused on means and averages as typical measures. Let's appreciate the value of dispersion. After all, we use it in political language all the time. Some very good political words are dispersion words. When we talk about polarization, we're not talking about the central tendency of a distribution. We're talking about its shape. You have a large percentage of people at one end of an issue and a large percentage at the other end polarized. Consensus is also a distributional word. Consensus would imply that values are clustered around one policy choice. Equality or egalitarianism suggests that the values are spread out among all units of analysis. In fact, let's think about a couple of scenarios here. This is an ideal case now. What does a variable look like when it has maximum dispersion, maximum spread? It looks like this. Of course, it's a stylized example, but this particular variable, which could be anything, has 12 values from code 1 to code 12. And notice that each value of the variable has the same percentage of cases, a little bit more than 8% of the cases here. This would be a scenario where a variable had maximum spread. So just sort of keep that idealization in mind. A variable has minimum dispersion, logically enough, if it looks like this. If 100% of the cases are at any one value, I just drew it here at value number 1, but you could have that 100% bar anywhere. And this is a scenario where the variable has no variation or no spread. All right, let's talk now about, with these sort of concepts in mind, the central tendency and dispersion. How do you analyze and describe variables? Frequency distributions. This is tabular data. You create a table of frequency that shows a frequency distribution. Bar chart is a visual expression of a frequency distribution. It's the graphic companion of frequency distributions. Box plots can be used with intervals and ordinal variables that have a lot of values. This is also, box plots emphasize dispersion. They show you central tendency, but it also can be a very good idea of dispersion. And let's look at an example. We'll just get sort of used to doing this. Here are the examples that we'll be talking about. The nominal level, region of residence. 2 ordinals, religious attendance, degrees of attendance at religious services, ideological self-placement. And we'll look at 3 interval level variables, number of hours that people spend watching television, support for spending on government programs, and feeling thermometers. We'll use that to show box plots. So I want to sort of mix up here variables in terms of whether their interesting property is their central tendency, and would it be okay to use the central tendency to describe typical value, and also showing how interesting variables can be that have dispersion. Now here's a properly constructed frequency distribution of a 2012 General Social Survey question or variable, region of residence. Actually, I think this might be census division, but you can see there are 9 values here. New England, Middle Atlantic, East North Central, West North Central, and so on and so forth. There's one column here that labels the values. There's a column, the next column shows the raw frequency, sometimes called the count of cases within each value of the variable. And then at the bottom, there were a total of 1,975 respondents in the survey. And then the third column shows the percentage of cases at each value of the variable. So clearly, if you divide 101 by 1,975 and multiply by 100, you get 5.1%. Let's just review that. 3, sometimes 4 columns, because in ordinals and intervals you add a 4th column. Column 1 labels the variable's values. Column 2 shows the raw number of cases in each value. Column 3, the percentage of cases in each value. And then for ordinals and intervals, we add a 4th column, the cumulative percentages, showing the percentage of cases in or below each value. This comes in handy. In fact, it's essential for determining the median value of the variable. So here's a graphic that accompanies this frequency distribution. And you can see I made some marginal notes here. Obviously, the mode of this variable is South Atlantic, that has the highest percentage of cases. This variable has a fairly high degree of variation or dispersion. I mean, if you go back and think about that scenario of maximum dispersion, and then think about that scenario of no dispersion, minimum dispersion, one would have to say that this particular graphic comes, if you have to judge it, you would put it closer to that maximum dispersion. There are just a lot of cases that are not in the modal category, which is South Atlantic. This is the mode, since it's a common most value, but there are just a lot of cases in these other values of the variable. So I wouldn't say that the typical respondent lives in the South Atlantic region. I would say the most interesting property of this variable is how spread out the values are. What did we just see? The variable's values appear on the horizontal axis. The percentage of cases in each value are recorded on the vertical axis. It's just a way of expressing the frequency distribution. You can use bar charts for variables at all levels of measurement. All right, let's move up to an ordinal now. This is a really interesting variable that it's over the years, the shape of this variable has changed, but it has always had this basic interesting appearance. This is attendance at religious services, and it's an ordinal because those respondents who never attend or attend less than once a year are here, and then by rank we go up in attendance levels all the way to every week or more frequently. I have the label bimodal here. What does that mean? It means there is a mode, technically never or less than once a year is the mode, the common most value. It contains 30.3% of the cases. But notice the polar opposite response, 26.2% fall within every week or more. So I wouldn't even bother to describe the central tendency of this variable, although we will, just for illustrative purposes. I would point to the fact that it sort of approaches that idea of polarization, where you have 2 clearly distinct modes and a lot of thinness through the middle ranges of this variable, through the middle categories of this variable. The median, how do you find the median? Go down the cumulative percent column until you hit or exceed 50%. The median of this variable must lie within several times a year, because that's got the cumulative percentage marker of 54.1%. And you can see that here. So the central tendency, the measure that we'll use with the ordinal, of course, is the median, and it tells the story of the median, but it ignores the most interesting feature, which is this bimodality of the variable. this variable comes closer to the maximum dispersion scenario than to the minimum dispersion scenario. If I had to choose, I would say this is closer to that being completely spread out. Remember, no dispersion would be all the cases would be within one or two very closely related categories of the variable. Here's another example of an ordinal. This, is, of course, is a very familiar measure of ideology that you see in the surveys. This is out of the GSS 2012. We hear a lot of talk these days about liberals and conservatives. I'm going to show you a 7-point scale on which the political views that people might hold are ranged from extremely liberal, 0.1, to extremely conservative, 0.7. Where would you place yourself on this scale? Now, again, appreciate why this is an ordinal. I mean, this is measuring, the way it's set up, degrees of conservatism. From code 1 at extremely liberal to code 7 at extremely conservative. So you can rank respondents in terms of how liberal or conservative they are. Now, this is a good case where certainly you could use the central tendency to characterize the variable. Notice that the mode, with 38.5% of the cases, is moderate. And notice that the median, cumulative percentage 65.4, the median must also fall within the code moderate. So this variable has it's well behaved, I guess I would say, in terms of its shape. The extremes are thinly populated, and then when you get closer to the middle, you get a more clumping of cases. So here's what this looks like. It often makes perfect sense to rely on a variable central tendency as a shorthand summary, and I think that would make perfect sense here. This variable comes closer to the minimum dispersion scenario. Why? Because it has a clearly prominent median in mode, and the other cases are clustered closer to that median in mode. All right, let's move up again. This is an interval level variable, and there's one additional point I'd like to make about this. This is question. On the average day, about how many hours do you personally watch television? So this is an interval of people say how many hours they watch, and you can see the distribution here. I'm going to find first the mode and median. Let's see, let's go to the mode. The mode is right here at 2 hours, containing 26.4% of the cases. Indeed, that's where the median is too. Cumulative percentage, 55.2. So we jump from 1 to 2 hours. We're landing in the middle of the distribution, which is the median. Now, interestingly, the mean of this variable is almost 3 hours. How did that happen? How did we get two measures of central tendency that agree, and we get a mean value of 2.93 after you ask the computer to calculate the mean? The reason for that is this variable is skewed. And specifically in this case, it has a positive skew. Positive skew is produced when extreme values, a few extreme values, populate the upper end, the positive values of the variable. Extreme values in the positive tail pull the mean up off the center of the distribution. So these cases out here, these diehard TV watchers who are looking at, they're watching 18, 20, 22, 24 hours a day, exert what statistically is called leverage. They put leverage on the center of the distribution and pull the mean up. So in this case, it would be more truthful and accurate to use the mode or the median. I would use the median to describe the central tendency of this variable because the mean is a distortion. A lot of demographic variables have means that are skewed, and that's why we often use the median for variables that describe, say, income, for example. All right, now this isn't to say that all variables are skewed or that skewness always produces distortions that that would suggest you should use the median instead. This is a variable that would be a good measure of our economic liberalism concept or measure that we talked about earlier in the book. This is support for spending on 17 programs, and it's constructed by simply asking respondents the number of programs they think we're spending too little. There's too little government spending. So if you say there's not too little spending on any of these, you're way down here. That'd be like a low level of economic liberalism. And if you think we're spending too little on all 17, you're way up here. So this is a nice scale that measures economic liberalism. Let's find some stuff here. We can find the mode is right here at 8 programs. That's the modal value. Again, appreciate the fact that a lot of cases are clustered pretty closely around that modal value. Where's the median? We'll go up here. It almost is 7, but not quite. The median also is 8. So we got a mode of 8, a median of 8. We got you can tell from the clustering here, it's a fairly symmetrical distribution. Here's what it looks like graphically in a bar chart. This distribution has a mild negative skew. The only way I know that is I asked the computer to tell me what the skewness was. It pulls the mean down slightly to 7.69. Even so, it would not be misleading to use the mean as the best measure of central tendency. We try to use the mean when we can, because when you use mean values instead of medians, it permits you to use more powerful data analysis techniques. But I'm using this here as an example of a distribution that is symmetrical, not terribly distorted. So you can use the mean. Not a lot of skewness here. Okay, finally, let's talk. This is an old measure of variation and central tendency. It does have a measure of central tendency in it. A box plot rendition of this does. That's enjoying something of a renaissance, so let's have a look at it. This is a non-statistical measure of dispersion for interval and ordinal variables, ordinals that have a lot of values. What is the interquartile range? All right, it's especially informative when you're going to compare two distributions, and that's the example we'll have here in a minute. Here it is. The interquartile range is defined as the range of a variable's values that defines the middle half of a distribution. What's meant by the middle half? That is, between the upper boundary of the lowest quartile, which is the same as the 25th percentile, and the lower boundary of the upper quartile, the 75th percentile. So imagine if you look at the middle half of a distribution. The middle half must fall between the 25th percentile and the 75th percentile. So it gives you an idea just how things are spread around the middle. And of course, we'll see it graphically in a box plot here. Now, this particular example uses a couple of variables that are treated as interval level variables in the American National Election Study. These are the feeling thermometer scales. In the feeling thermometer scales, respondents are asked to rate political objects, groups, political personalities on a scale of 0, which would be that the respondent feels cold or negative toward that political object, and 100, in which case the respondent is communicating that they have a very warm and positive feeling. So it's really a 101 point scale from 0 through 100, and we can get pretty fine measures of how people feel, kind of affect they have toward different groups. Okay, having said that, here this table compares two religious groups, Mormons, Christian fundamentalists. Notice the mean value of Mormons is about 50 or 51. Christian fundamentalists a little bit lower, but I would say just looking at the numbers up here, these two distributions would appear to be quite similar. They have the same median, 50. They have the same mode, 50. They have similar means, right around 49 and 50. But down here, look at the percentiles. For Mormons, the 25th percentile, the point at which 25% of respondents fall at or below that value, is 40 degrees. That is 40 degrees on the feeling thermometer. There's the median again. The 50th percentile is 50. And then the 75th percentile is 60. So that means that half of the distribution of how people feel about Mormons on the scale ranges between a rating of 40 and a rating of 60. So that's like a 20-point interquartile range. Now, switch to Christian fundamentalists and notice even though the median is the same, as we've seen, a score of 50, there's much more variation, considerably more variation in how people rate Christian fundamentalists. From 30, that's a 25th percentile, to 70, that's a 75th percentile. So you can imagine that the evaluation of Christian fundamentalists on the feeling thermometer scale is more spread out. Here's what the box plot looks like. And now you know why those numbers look like they did. Here's that fairly tight interquartile range. The median, in the part of the box here, the median is the horizontal line at the middle of the boxes. You can see they're the same at 50 for both. And the edges of the box define the 25th percentile is the bottom edge of the box. 75th percentile is the top edge of the box. So again, there's that about 20-point range for Mormons, and a much larger spread for Christian fundamentalists. Box plots are really great for capturing and comparing, actually when comparing two distributions in terms of their central tendency and spread. The other items here are the lower hinge and the upper hinge are the minimum and maximum values as long as those aren't extreme. If they're extreme values, they're represented as outliers. And you can see the Mormons have a tighter spread around the middle, but there are several outliers here giving very high scores and very low scores.